This video is on graphing quadratic inequalities. Graphing a quadratic inequality is similar to graphing a linear inequality. We first want to graph the related equation, then determine whether the boundary line is going to be solid for a less than or equal to or a greater than or equal to, or is the boundary line going to be dashed for a less than or a greater than. We want to test a point that's not on the boundary line to determine whether the region inside the parabola or the region outside of the parabola should be shaded, and then we need to shade the region that contains the solution. Let's take a look at a couple examples here. Our first one is the inequality y is less than 2x squared plus 1. So we need to graph that and name one solution to the inequality. Well, looking at that, I can tell that my vertex is going to be the point 0, 1. I also know that it's going to open upward. Okay, and I know that since this is a less than, it's going to be dashed. And where is y going to be less than that? I'm probably going to be shading on the outside of this, of the parabola. So but I'll test a point just to make sure. So let's go ahead and we have the point 0, 1, okay, and maybe I'll make just a quick table of values here to get a few more numbers to go in there. So 0, 1, and then when I do -1 and -2 and 1 and 2, so plugging in 1 I get 3, so -1 will also give me 3. Plugging in 2 I get 9, and -2 will also give me 9. So 1, 3, and 2, 9 is going to be way up there somewhere. We're not going to worry about that too much. -1, 3, and then another one here. And this is going to be dashed, so I'm going to try to draw this parabola here with some dashed lines. Okay, and I believe I'm going to be shading on the outside, but let's go ahead and test a point. I'm going to choose, if the graph does not go through the point 0, 0, let's always choose that because that's a nice easy number to plug in for x and y. So is 0 less than 2 times 0 squared plus 1? Well, that just becomes a 0. Is 0 less than 1? Indeed it is, so I want to shade the region that contains the point 0, 0, so that would be all of this area out here gets shaded. I'm not going to worry about shading the whole thing. So all of this area outside of the parabola. Name one solution to the inequality. Well, I know that 0, 0 is a point. I also know that the point 1, 0 is going to be a solution for this inequality. And in fact, every point in this area out here works in this inequality. Let's take a look at another example here. Here I have y is greater than or equal to x squared plus 4x plus 3. And looking at that, I realize that that can actually be factored into x plus 1 and x plus 3. And that tells me that I'm actually going to have y-intercepts of x-intercepts of -3 and -1. Now let's go ahead and get our vertex. So x is the opposite of b, -b over 2 times a, or -2, so that makes sense. That would be right in the middle between those two. And then y is what I'm get when I plug -2 back into there, which is going to be -1. So my vertex is going to be the point 2, -1. Since this is a greater than or equal to, my boundary line is going to be solid. And choosing two other points, when I plug in 0, I'm going to get 3. That's my y-intercept. And then I know that symmetrically there will be another point over here. So I can go ahead and draw. This one was a little bit easier to draw. Oops. And since it's y is greater than, I'm thinking I'm probably going to shade inside here. But let's go ahead and test our point. Since the graph does not go through 0, 0, let's go ahead and test 0. So is 0 greater than or equal to 0 squared plus 4 times 0 plus 3? Well, that's 0, that's 0. Is 0 greater than or equal to 3? It is not, so the region that contains 0, 0 does not get shaded. So yes, inside the parabola here, gets shaded, and any point inside of there works. So for example, the point, if I wanted to do like the point -2, 2, that is a solution and a point that would work in this inequality. So in this video, we took a look at how to graph quadratic inequalities, which are actually quite similar to graphing a linear inequality. We want to graph the related function, determine whether the boundary line is solid or dashed, and then go ahead and graph the function and test a point that does not lie on the boundary to determine whether we're going to be shading inside the parabola or outside of the parabola.